This is Greg Pasternak from Riverside Life, and today I'm in a new region. I'm in the North Coast region of California within the South Fork Eel River catchment. We've measured a bunch of sites working together between UC Davis and Humboldt State University, and they had terrific field crews who came out and looked at a whole bunch of sites up here and measured their attributes. And we're at one of those sites today, which is on Tenmile Creek. In this tributary, when we look at the results here, it classifies the same way between the South Fork Eel regional classification and then the statewide classification as an unconfined site with a gravel bed and riffle pool morphology. So let's look at what that means. Well, first, if you look around me, around the sides, well, first, I say on this bank, there's actually a very high bank here. So reminiscent of what we saw in the South Central Coast, this is an entrenched river, and we have a very steep cut bank. You can see the roots and quite a bit of even undercutting deep under the roots there. So this site here is actively widening. On the other side, there's a really wide gravel bar on that side, and it's actually relatively dry. It's the beginning of the summer now. There's a little bit of water at the lowest level here in the pool, and so we can see that the valley here for sure is unconfined, although the site is entrenched. And then we come in, you look at the sediment, it is a gravel, so there isn't a lot of structural control taking place from the sediment, but it is characteristic of a riffle pool channel that you have this kind of gravel. And then if we look at the topography, the channel here is about 15 meters wide on average for its bankfull width and about 1.5 meters deep on average for bankfull depth. And when we look at the site, you see that there is some undulation, but the variability here is relatively low. So a relatively low coefficient of variation of depth, right, as you go down, although it's certainly present. But the width has a moderate amount of variability here. When you have a river that's this wide, then inevitably it takes a very big number of variation to get a big coefficient of variation. But the variability is really, really important, because you look at like the base flow channel here, there isn't even full flow going down the channel. So there's just like a pond of water that's sitting here. But you could imagine that at this low flow where this pool is, that it's really just quite narrow and not really, the width doesn't really come into play. But as this fills up and it spreads out, then the water is really going to it's going to get somewhat deeper, but it's really going to get a lot wider. And that extra width will prevent the water from getting fast. So it stays slow because all of that extra flow is going to cover the width of the channel. So that helps to promote deposition at this location, which is why there is a big riffle here. If you look downstream, down here there's a pool at that location, and along the bank over here, the whole bank there is coming together. So let me switch over to this side. So the bank is coming together, and on both sides we're getting basically a nozzle. We're getting like a valley-wide nozzle in this entrenched channel. I shouldn't say valley-wide, but entrenchment-wide. This canyon is all coming together, and then that is causing scour there. So width variability plays an essential role in explaining the structure and function of this stream. The classification of just saying, well, it's an unconfined gravel or riffle pool, yada yada, like in and of itself, those are just words, but they help to provide the context that in this setting, we're going to have processes that are driven predominantly by the width variability. And that's going to affect the habitats, like the substrate conditions, depths and velocities as a function of discharge. And then what sorts of refugia can organisms go and find as they are trying to cope with the flood or whatever the conditions are. So anyway, that's a summary of Tenmile Creek. Both classifications agree. The metrics all fit very well. This is a classic unconfined gravel riffle pool site in California.